Azure Traffic Manager gives you control over how traffic is distributed across your application's endpoints, which can be any internet-facing services hosted within or outside of Azure. It offers two primary benefits such as traffic distribution and health monitoring and failure. When it comes to the traffic distribution, Traffic Manager routes incoming requests based on one of the several customizable traffic routing methods, such as performance based or priority based. And when it comes to health monitoring and failure, it continuously monitors endpoint health and automatically reroute traffic if an endpoint fails. When a client attempts to connect to a service, it first resolves the service DNS name to an IP address. Traffic Manager uses DNS to direct the client to the best available service endpoint based on the selected traffic routing rules. Importantly, Traffic Manager is not a proxy or gateway. It doesn't handle the data flow between the client and the service directly, but instead operates at the DNS level, that is like a layer 7 application layer. Let's look at a practical example of Traffic Manager shown on the screen. In this scenario, Contoso Corp has launched a partner portal accessible at partner.contoso.com and hosted in 3 Azure regions. To maximize availability and ensure fast access for global users, they implement Traffic Manager for optimal traffic distribution. Contoso deploys their application in 3 Azure regions with the DNS names contoso-us.cloudapp.net, contoso-eu.cloudapp.net, and contoso-asia.cloudapp.net. They set up a Traffic Manager profile called contoso.trafficmanager.net and configure it with the performance routing method to direct users to the nearest and best performing endpoint. They configure their vanity domain partner.contoso.com to route traffic through Traffic Manager by creating a DNS CNAME record pointing to contoso.trafficmanager.net. With this setup, Traffic Manager directs each client to the fastest, closest endpoint, optimizing both performance and availability across regions. Let's understand how Traffic Manager handles client query. When a client requests the URL partner.contoso.com, Traffic Manager orchestrates DNS resolution to route the client to the most suitable service endpoints. Let's unfold the process, how this could work for the client. The client sends a DNS request to its configured recursive DNS service to resolve partners.contoso.com. This recursive DNS service, often known as local DNS, doesn't directly host DNS domains. Instead, it handles contacting other DNS servers needed to fully resolve the name. The recursive DNS service locates the DNS servers for the contoso.com domain and requests the partners.contoso.com record. Contoso.com DNS server responds with a CNAME record pointing to contoso.trafficmanager.net. The recursive DNS service now seeks the DNS servers for trafficmanager.net managed by Azure Traffic Manager. Traffic Manager's name server processes the request and select an endpoint based on endpoint status, endpoint health, and the chosen traffic routing method. Suppose contoso-eu.cloudapp.net is chosen as the best endpoint. Traffic Manager responds with another CNAME record pointing to this endpoint. The recursive DNS service now resolves contoso-eu.cloudapp.net by contacting its DNS servers, which provide an A record with the IP address for the EU-based endpoint. The recursive DNS service consolidates all results and returns a single DNS response to the client. The client uses this IP address to connect directly to the application endpoint, bypassing Traffic Manager itself. If the endpoint is secured, the client completes an SSL TLS handshake and then issues an HTTP GET request for login.aspx. The recursive DNS service and the client's DNS resolver cache the response. This caching speeds up future DNS lookup but can impact response time to endpoint failures or changes in traffic routing. Traffic Manager's TTL setting for DNS records determine cache duration, balancing between quicker failure response and reduce DNS traffic. Traffic Manager supports TTLs from 0 seconds up to approximately 68 years, which will allow you to adjust based on your application needs. This sequence enables Traffic Manager to provide both high availability and optimal routing by coordinating DNS resolution in real time and guiding clients to the best performing and healthy endpoint.